This video will be about the Newtonian fluid. The idea of a Newtonian fluid, or the basic idea of a constitutive equation, is to connect one state variable with another one. In the case of the Newtonian fluid, the idea is to connect the velocity rates and the stress tensor itself. So this would like to be a fluid property to model the equations or the conservation of momentum and to reduce the degrees of freedom of the conservation of momentum. So we assume we have local thermodynamic equilibrium and therefore Stokes' hypothesis. It is reasonable to assume, and was also experimentally kind of derived, that the transport process of velocity rates and shear stress are determined by a linear function of the gradient of the flow state variable. This means that we can connect, or we can derive a Newtonian fluid which has a dynamic viscosity and relates the stress tensor by the linear dynamic viscosity with the velocity gradients within the fluid, and that's basically the fact or the idea of a Newtonian fluid, that we can relate the stress tensor by a linear function to the flow gradients. At the results, having a Newtonian fluid, we can rewrite the conservation of momentum by the Navier-Stokes equation, and that's the main message I would like to give you here, that we define the Newtonian fluid, which is a linear relationship between the stress tensor and the velocity gradient by the dynamic viscosity, and additionally we can then use this Newtonian fluid to insert it in the conservation of momentum and arrive at the Navier-Stokes equation. Thank you for watching this video about the Newtonian fluid. In the next video we're going to discuss the Reynolds number.